So this is like this will image particularly this pack. So you know about SciPy, right? So from SciPy and miscellaneous, you can if you use this function, you will be able to import this into the image. So this is only a single image.
Okay.
And these are plotting that image plot I am shown, that particular image, and this is the title. These are all particularly for matplotlib.py.
Okay.
There is nothing much in it. There is no technicality or anything. Just this is, normal user convention.
Yes.
Then this part will convert it into convert the image to float. So this is because you can see this is not a RGB image, right? First you need to convert it to RGB image, and then since this is that RGB image. So to do that, you can if you convert the integer points to float point, the default color map using previous step, this will convert it to RGB image.
Okay.
Right? And this is plotting that image. So these are all convention. There is nothing much technicality in it. And this is so basically what we're doing is we're just this is a big image. This is a I think 256 cross 256 image. Now you want us sorry, this is
512, yeah.
512 cross 512 image, and it's in and data type is float 64. And for this one, I think it was I got to int 64. So the data type is converted using this command, and so next step is to take a crop of that image. This is the full image 512 cross 512, and we just want a small portion. Let's say this portion. We want just this portion. We can do that using this command.
Okay.
Right. So this will take out this part. So this is the coordinate basically from 300 to 4. This is the x coordinate from 300 to 400. This is the y coordinate from 260 to 360. And if you change this coordinate, you will get some other portion.
Yes. Okay.
But let's say we want equal. We can do that. Right. That way, you will be able to crop that image. And you can do your experiment. You can crop some other portion as well. And this is for I am show and title. This is same as the other commands. So this is the main convolution part.
Yes.
So for convolution, right? For what we are doing is we have the image and we have one kernel. So these are the two inputs for the convolution function.
Yes.
So this is the pseudocode. I'll directly go to the code. So what it is taking is the image and the kernel, and it is convolving that kernel over that image. So first, what it is doing is, so this image dot shape 0 will give the height, and image dot shape 1 will give the width of the image. Similarly, for kernel, we can have the kernel dot shape 0 will give the kernel height, and kernel dot shape 1 will give the kernel width. This is a normal Python syntax. Then the other thing is, now our job is to shift this kernel over this image. This is like you can say you have a puzzle, and over that you have one block. You are just shifting that block and multiplying that block with the image elements and shifting it. That will basically change the input image to some convert image, right? So for that you need the the kernel is divided by 2. Kernel height and kernel width both are divided by 2 because that will give the mid position of the kernel, right? So if we have a 5 cross 5, let's take the example of 5 cross 5 kernel, then the midpoint will be 3,3. Sorry, no, 1, 2, 3,3. Right. So that will be the exact position which that corresponding to that position of the image your convolution will happen. So what you are doing is this is for the height part. So initially you're writing the for loop for the height and then for the width. Before that so this is for the convolutional image. So you basically taking the np dot zeros, like I mean this is a zero image, there is nothing in it. And then for the image height and width next your job is to shift that kernel. So this is the midpoint. So midpoint value is like all the corresponding elements of the image. This is the image portion and this is the kernel. These two are multiplied.
Okay.
These two are multiplied and added to the accumulator value.
Yeah.
And then again we are incrementing on m and n.
Yeah.
So this is for a fixed kernel. The kernel is fixed. Next, your job is to shift that kernel. So this will change that kernel.
Okay.
Understood, right? This
Yes,
part.
yes, yes.
And so that's what we is written here. For each element in kernel row, if element position corresponding to pixel position, then multiply element value corresponding to pixel value, corresponding image value and
Pixel
kernel
okay.
value and that image pixel value are multiplied and added to the accumulator.
Yes.
That is stored in the and then the final image is returned. That is the convolution function.
Yes.
So next it is showing for a particular 5x5 kernel, and the image is that cropped image. So this will show you how the filtered image will look like.
Yes.
Right. For your experience, you can take some other values as well. Like this, this is a particular. This kernel is particularly 5x5 kernel, and all corresponding elements are 1. That's what this np.1 is doing. And you can take some other size also. I mean, that will also work. Instead of 5, you can take 7. That will also work. I mean, the odd number is usually taken so that you can have integer middle point. That's why the number is 7, odd number. And this basically doing the blurring the image. The image is blurred.
Yeah.
So let's try to learn this. So it's the same mesh. But there are some other packages. I mean, like it's not sci-fi, from where you can fetch some different images at different time. So you can use the rand function like that, and you can have some other images as well. You can do that experiment. In Colab you can do that because you don't need to install anything else other than you just need to open Colab. That is very user friendly.
Okay.
And this is basically converting that image to grayscale image. So before it was cropping from 200 to 300 to 400. Now it is cropping from 300 to 500 and 260 to 460.
Yes.
So it will be bigger.
Yes.
So previously it was much more blurred. So and the image size is 200 cross 200. The data type is 464.
Yes.
Let's move back to because we'll be using the 100 plus 100 size image. So that's why so this is a smaller image. That's why it is much more blurry because the pixel size are getting increased in this case.
Yes.
So you understood the convolution part, right? This part you understood. This was,
yes. Yes.
And this is doing the convolution. The function is called, and this is the image crop and the kernel. And we're using 7. Now we can use the 7%. Let's see what happens with 7%. So this is much more blurred. If you increase the size of the kernel, it will be much more blurred. You can take some other size. The blurredness will be state 9%. See, right? So blurredness is increased. And if you use 5% step, let's say 3+3. So it will be much more sharper than this one.
Yes.
You can experiment with some other kernel as well. So this was the blurred kernel. You can use some Gaussian kernel or some other kernel. You can search it on Google. You will find a lot of. You saw it in the previous slides. You were able to see that those different types of kernels.
Yes.
So the next part is the border handling. So what this is doing is, so in that image, as you can see that there is a black stripe at the border of the image.
Yes.
Right. So this is because we didn't extend the image size, and the corner values are not getting converted. That's why there is some black portion in the image. I mean, in the input image there is no black stripe. You can see, right?
Yeah.
But in the filtered image there is some black stripe. So that is because that portion is not getting converted. That portion is zero. Zero is black. So to handle that border, what we can do is we can pad that border with zero values.
Okay.
So this is that extended convolution. So this is basically extending that image height and image width with zeros. So image.shape will get 0 will give you the width, plus you are taking the kernel shape -1. So this will increase the image on both sides, on the left as well as the right. And similarly for height, you can increase it with the kernel dot shape 1 -1. Right.
So I didn't understand that.
If you have any pen and paper, you will be able to understand better. So like so let's take this example. Let's take the image size to be 100 cross 100. Okay. And the kernel size is 5 cross 5.
Okay.
So let's say you want to convert the topmost left point. So let's take that is 0,0 point.
Okay.
So then if you fix the kernel on that point, then the kernel the how many positions are left to the left of the kernel? There are 2 positions are left, right? 5 minus 2, because your center is at 0,0.
Okay.
You can visualize it, right? So on the left side you have 2 positions left. So that's why you are extending it by and let's take the example of right side. Let's take the example of 0,100 position. If you fix your kernel at that position, then on the kernel right side you will have 2 positions left. Right. So overall that means we need to increase the image on the left side by 2 positions and on the right side by 2 positions. That is kernel width -1, 5 -1.
Okay.
So that's why this width is getting increased by image width plus kernel width -1.
Okay.
So if your kernel size is 7 cross 7, then you need to increase it by 6. It's like that. And similarly for height also. When you take your kernel and put it on the leftmost and the 100, 0 position, then you need to increase your height.
Okay.
That's why this kernel, this image padded images height and width are getting increased. Now, so this part what it is doing is, so this image padded is now with zeros. All the values are zeros. np.zeros will basically put zeros in all those. This will increase the size of the image, and the positions will be 0. So this is basically matrix. So in that matrix, we need to put this image, our input image, into that matrix. but in the border, all the values will be 0.
Yes.
But in this at the center, the image will be placed. So like let's take the example of the 100 cross 100 and 5 cross 5 kernel. And then the size of this image padded will be 102 cross 102. Sorry, 104 cross 104, because kernel size -1, 5 -1, that's why 104 cross 104.
Okay.
And at the center, 100 cross 100 image will be placed, and on the border there will be 4 pixels which will be 0.
Okay. Okay.
On the left side there will be 0 pixels, on the right side there will be 0 pixels. So that will be the image padded matrix.
Okay.
So that so basically what you have done is you have increased the size of the image.
Yes.
That's that function. Now you want the height of that padded image. So this is the same image width plus kernel width -1, and the sorry, height -1, and for width also same thing, because it's basically the square, and the width is also getting increased by kernel shape -1.
Yes. Yes.
Then the kernel height is kernel shape also is same as the previous one, and the convolution operation is also same. There is nothing changed in it.
Okay.
You understood this part, right? How this kernel is getting multiplied and then again shifted and again multiplied in this loop.
Yes.
And this part, and then finally it will return the image. And let's try it out. So this is to test our result. So this is the extended image. You can see, right? In that crop part. This is the extended convolution. So what it is doing is that cropped image is having zeros at the border, and that zeros are getting showed here.
Oh, yes.
And the size of this extended image is 104 cross 104.
Yes.
But at the center, we have this 100 cross 100 image. This is that part. Okay. And for your clarification, you can also erase this border. That is also possible. And this is the reference result. The reference result is using the SciPy convol. This SciPy convol function will also do the same convolution. It will also, it is same as our written extended convolution function.
Okay.
And next, this SSG function. What it is trying to show is that these two images are same. So this is basically taking the difference of this our filtered image and the reference convolutional result, and that is basically squared. So here you can see the explanation. The sum of square difference, and the output should be 0. Then your result is correct. Your extended convolution result is correct, and this is basically that.
Okay.
And here also you can see I have taken 22102 and 22102 for height and width. That is the center part. I have not taken the border to 0 values.
Okay.
Right? Because that is 0. That part I have extended for my purpose. That is not required, and the result is 0.
Okay. Yes.
So this is giving you the extended convolution part. Next, you can use some other. So these are some other filters. So in the previous case, the convolution kernel was all of them. This is random.
Yeah.
And here the kernel was np.1s. All the elements were 1. This is basically the blurring kernel.
Yes.
But this kernel is not random. This is not one kernel. This is np.random.rand. Okay. But it is also doing the that blurring operation, because Even if you take whatever element you want, it will do the blur.
Okay.
And the next operation, next important operation is getting the horizontal gradients and vertical gradients. Okay.
Yes.
So this is the kernel for the horizontal gradients. So,
Yes.
so the leftmost column is 1 to 1. The rightmost column is exactly opposite of the leftmost column. So this will give you the horizontal gradient. And for vertical gradient, the topmost row is 1 to 1. And the bottommost row is exactly opposite of the topmost row.
Yes.
This will give you the horizontal, and this will give you the vertical. And this one, this is the diagonal gradient. So, so as you can see, the I mean, this is basically a skew symmetric matrix. Right. So this element is exactly sorry, this is symmetric matrix, not skew symmetric, because -1 is getting replicated as same as -1. 1 is same as 1. So if you use this kernel, then you will get the diagonal gradient.
Yes.
So you can see this is the horizontal gradients. So you can see this edge, right? This is horizontal. This is horizontal. This is vertical.
Vertical.
And this will give you the both gradients.
Yeah.
On the diagonal.
Yes.
You can use some other style as well instead of this one. I mean, then the kernel will change. Here it is 3 cross 3 kernel. You can use 5 cross 5. In that case, you need to change this 1 0 1 2 1 2 1 2 2 1 like that. No, I think the kernel will be different. I don't exactly remember. You will find it on Google. Let's Google operator. So this is 3 procedure. You can see this +1 +2 +1, and this -1 -1 -1. Similarly, you might get some 5 + 5 as well. These are all kind of methods. So you can try your own kernel. You can even invent your own kernel. I mean that can do some other operation on the image.
Yes.
So this is the unsharp masking. So the unsharp masking is we'll try to remove the we'll try to remove the unsharpness of the image. So as you can see, this is the unblurred. The blurred image is trying to unblur the image. This is basically taking the centermost pixel value.
Okay.
This is the unsharp masking kernel.
Oh. Okay.
And you can also have Gaussian blur kernel. This is the 5 cross 5 Gaussian blur kernel. So first you take NP dot zeros. This is basically 5 cross 5 matrix with all the values as zeros. And of this matrix, the 2.2 position is first taken as 1. And then that that is basically not, then it is normalized with the
Okay.
some values, and the size is this is basically taking the half of the size, and this will give you the normal value, right?
Mm.
1 by square root of 2 square root of 1 by sigma square root of pi. Sigma is basically taken as 1.
Yes.
So that way you can create the Gaussian kernel.
Mm.
This is the Gaussian kernel, and
Mm.
see the centermost values are the maximum values.
Yes.
So as you go to the left, you will see that the values are decreased. So this is
Yes.
0.002. This is 0.013. This is 0.021. And again on the right side, it is getting decreased. 0.021. It is getting decreased 0.13. And this value and this value is the same.
Yes.
And this value and this value is the same. Similarly,
Yes.
for rows also you can see. This is the centermost value. This is the maximum value. And on the if you go up, it will be 0.09. It is decreased again 0.02. It is again decreased, and this value is the same. So this is basically a symmetric matrix, and on the middle point, this has a maximum value. That is the speciality of the Gaussian kernel. You can see, you know about Gaussian kernel, right? So it has like a hill kind of shape.
Mm. One more thing, for unsharp masking, we don't need to write any other code or something,
This will just take the this is the unsharp masking kernel.
because we had a task, an unsharp masking kernel. Uh,
What's the
all
task?
these, yeah, all these codes were given already. Mm.
This was given. Okay. So, okay, I'll check this one. So what was it? There's no description.
Sorry.
There's no description of that. What exactly? It is just saying unsharp masking kernel. Right.
Mm. Okay, we have to change it.
I think not be zero. Kernel. Okay, I'll try to do it. And
Mm.
this part I so that part is different.
Yeah.
And the Gaussian kernel you understood, right?
Yes.
This is the A50. I mean, this part also, I mean, you can try to, I mean, I didn't go into much detail. This will basically do the 2D FFT of the, we will try to use the convolution theorem of 2D FFT.
Okay.
Uh, so, so this one also you need, right?
Yeah.
Or this one, I didn't get time to look at it. Maybe next time I'll show you both of these two.
Mm.
That will go for you, right?
Sorry.
So this FFT convolution, uh, you can try by yourself, and if you face any issues, you can let me know. And I'll also, I mean, I didn't get much time to look at it, this FFT
Yeah.
part,
Yeah. Yeah.
because so this is basically similar to the convolution that we have done, the
Mhm.
convolution and the extended convolution. This will
Yes.
just basically take the FFT of the input image and the
Mm.
FFT of the kernel. And in
Okay.
case of basic convolution, what is happening is image is convolved with the kernel, but in case of Fourier transform, it will just multiply. So that operation, I have to check. I mean, is not that difficult. Maybe if you give me some time, I'll give you the code.
Yeah.
This one and the unsharp masking.
Yeah. The Gaussian I did it. Is that right?
The Gaussian is correct. So
Yeah.
this code you wrote by yourself.
Yeah.
So what exactly is this code? I mean, this is a lab. I mean, you need to. Is your assignment or the practice problems?
Like practice problems. They are giving us to practice in.
This will get test result. So the FFT part you understood, right? FFT part.
Yeah. I'll try it out.
So this is basically easy in MATLAB. This FFT part, because I saw it in MATLAB, and basically you can use the normal convolution. I mean, this is not that normally people doesn't use it right now. You can use it for faster computation. So
I'll try it. No, only those 50 and the this thing. What is it? Unsharp masking. Yeah.
Okay, if you maybe tomorrow I can show you the code. Tomorrow or day after tomorrow.
Yeah, sure. Yeah.
One of these two.
Yeah.
You can also try by yourself. I mean, it's not that difficult.
Yeah, I'll
You
try
can
it.
cross check it with my answer and your answer.
Yeah. Yeah, sure. I'll do it. I'll check it out.
And I also let you know the code.
Yeah. No. Can I share my screen?
Yeah. Macro stops.
Yeah. The same thing, border handling. I did this. Is this right? Just one taking image. Oh, this thing should be image height. Why is that coming?
So image height. What is the no, good up. Index work.
Hmm?
Index, I mean, the size is fair change, right? From 100 plus 100, it is changed to 104 plus 104. Four, four, four. Yes. Let me check. So
Hmm?
in accumulator, it will be image padded.
Accumulator?
This is not working. Right?
I'm getting this error.
Oh, so you need to increase the size of your image convolve also. Oh, so this will be so no. So in the line number 26.
Image padded. Yeah. Is that image padded?
It will be image padded. Yes. So here, so in SSD, you need to for filtered, you need to take that two. So in filtered, you saw it, right? Filtered in third bracket. You need two is two.
But I can't change this. I'm not supposed to change it.
This part.
Yeah. I
Then
can only
you
change.
can take so instead of extended convolution, so you can write one extra line, right?
Here we can't write any code. Only in this part.
So then you can return instead of this part, you can write return image convolve. Convolve that required your size. Kernel minus one third bracket. Kernel height minus one colon image height kernel height minus one. minus 1. No, it will be height. No, take height, height colon image height. It is a kernel underscore height. It is minus 1.
Height minus 1.
No, minus 1, erase that. It is minus 1. Colon image height plus height. Similarly for width.
So next bracket.
Comma. Comma.
Oh.
Then should be height. Try how much is
Is it image height?
not image height. It should be that height, that kernel height by divided by 2. Then try with the height colon image height. It is that plus height part. On the previous cell.
What?
Did you run the previous cell? And this cell did you run it?
Yeah.
No, not this one. The next one. No, not this one. The previous one.
I ran that.
This one. Did you run it?
Yeah, I ran.
So then why is it still 0%?
Same error is coming.
Okay, so basically you cannot change. Okay, then let me do one thing. I'll try to modify this code and share with you the code.
Okay.
We cannot basically we cannot change the this part, right?
Test. Yeah, test part we can't change. Other than that, here and all we can change.
Okay, I'll modify that part and I'll share.
Okay.
So basically three things, right? The FFT part, that unshort masking, and this.
Yes. Yes. So
Also,
by when will
you
I'll try
also
it.
tried.
Yeah.
We
Yeah, I
can
should
cross check.
try. When will I get it? Code.
When do you want? You can call
No,
it.
just asking. No, it's just asking.
I can have it by Tuesday or Wednesday. Will that be okay?
Oh, yeah. Okay, fine. Yeah. Yeah, it's fine. Okay.
Anything else?
When I did this without like this part and just this. It's coming like this.
So correct.
Not zero, right?
Yes, it's not zero.
Mm.
Check this code. This code is did you share?
Yeah, it's there. It's commented. Yeah.
Okay, then I'll check this part also.
Yeah. Oh, that's it, right? Mm. Yeah.
Yeah, we can stop the recording.
Please stop the recording. Yeah. Hello.